Welcome back to Basic Science Classroom. We are discussing our second chapter, Wonders of Visible Light. So in the last video we discussed about the different objects which reflects light and regular reflection and diffuse reflection and how we are able to see objects. Today we are going to discuss something more about the wonders of visible light. Examine the surface of a plane mirror. What are the peculiarities of its surface? It has a plane surface. A mirror with a plane surface is called a plane mirror. Now, what if we look at a steel plate or an aluminum plate instead of a mirror? How does the face appears? Does we get a clear picture or the clear image of our face? No, our face does not seen clearly because it does not reflect light completely. We can do an experiment. Place a mirror on a table in a dark room and lit a torch. What happens when the light fell on the mirror placed on the table? Repeat this activity by directing the light on the mirror from different direction. Do you see the light ray that moves towards the mirror and those that are reflected from it? The light ray falling on the mirror is called the incident ray, and the ray reflected from it as a reflected ray. This you can do it from your home. So, what is the incident ray? The light ray which is falling from the torch we lit to the mirror is called the incident ray, and the light ray which get reflected from the mirror is a reflected ray. So we studied two new terms, the incident ray and the reflected ray. With the help of your textbook, you can clear these two terms, incident ray and the reflected ray. So we studied what is incident ray and what is reflected ray. Next is angle of incidence and angle of reflection. From this diagram, you can see angle of incidence, angle of reflection and a normal line. The line drawn perpendicular to the mirror at the point of incidence is called the normal. The point of incidence you can see in the picture. It is the point where the incident ray get pointed or incident ray stuck as the point of incidence. So normal is the line drawn perpendicular from the mirror at the point of incidence is called normal. And we are measuring the angle of incidence and angle of reflection with the help of this normal. The angle between the incident ray and the normal is the angle of incidence. The angle between the incident ray and the normal is considered as the angle of incidence, and the angle between the reflected ray and the normal is the angle of reflection. Hope you understood what is angle of incidence and angle of reflection. Let's check this video.
Reflection of light. Have you observed the path of light when it strikes the mirror or wall in daily life? Does it move along straight line path or changes its direction? Definition. When light ray strikes the boundary of two media such as air and glass, a part of light is turned back into the same medium. This is called reflection of light. A highly polished surface, such as a mirror reflects most of the light falling on it. Laws of reflection. 1. The angle of incidence is equal to the angle of reflection. And 2. The incident ray normal to the mirror at the point of incidence and the reflected ray all lie in the same plane. These laws are applicable to all types of reflecting surfaces, including spherical surfaces. Types of reflection. The types of reflection are regular reflection and irregular or diffused reflection. Regular reflection. It occurs when a beam of light falls on a smooth and polished surface, such as a plane mirror. Irregular reflection. It occurs when a beam of light falls on a rough surface, such as wall of a room. Incident ray. Light ray striking a reflecting surface. Points of incidence. The point at which the incident ray strikes the reflecting surface. Reflected ray. The light ray obtained after reflection from the surface in the same medium in which the incident ray is traveling. Normal. The perpendicular drawn to the surface at the point of incidence. Angle of incidence. The angle which the incident ray makes with normal at the point of incidence. It is denoted by the letter I. Angle of reflection. The angle which the reflected ray makes with the normal at the point of incidence. It is denoted by the letter R.
Let's do another experiment. Fix a small mirror on one side of an inner side of a transparent vessel. So take a transparent vessel and place a small mirror on inner side of this vessel. Cut out the shape of a protractor on a chart paper and mark the angle. So you take a chart paper and cut out the shape of the protractor and mark the angles on the chart paper. Place the vessel on the chart paper. Take water in the vessel. Add a few drops of milk or soap solution, or even you can use Dettol. This is to see the path of light clearly. So you have taken a vessel, then you placed a mirror in inner side of the vessel, then pour some water in it. Then in the water you can add some milk or soap solution or Dettol solution, etc. Then place the vessel in the chart paper which you have cut out in the shape of a protractor on which angles are marked. Place a laser torch at an angle and focus its light beam on the mirror. The light reflected from the mirror can be seen. This also you can do in a dark room. You can do this experiment from your home. Otherwise, you check out this video.
First of all, we will take this plain sheet of paper. So did you notice that we have drawn a straight line in between? So there is a purpose behind that. So what we do is, now you take this transparent box and place it on the sheet of paper. So one interesting thing to be noted here is, we have also kept the protractor. In fact, we have pasted it on this box with the help of sellotapes. Now when you place this box, make sure that the central line of the protractor, the one showing 90 degrees, is along this red line which we have drawn. So now you understand what is the red line that we have drawn. This red line is nothing but the normal. Okay, so now the next task that we need to do is, we need to place the mirror. So the mirror will be placed somewhere here. So for that we need a stand for the mirror. So we will make use of these clips. Now the stand is ready. So what you do, you place the mirror exactly on the base line of the protractor. So this is important. So make sure that the mirror is lying exactly on this line of the protractor. So now this basic setup is ready. So you might be curious to know what exactly are we going to do with this setup. So let us quickly look at this. So we all know what is reflection of light. It is bouncing back of light from a smooth shiny surface. So whenever an incident ray strikes a surface that is smooth enough, it gets reflected back such that the angle of incidence is equal to the angle of reflection. So you see, we have already done the same setup. So you have a mirror here. So here we have the mirror. So now all we need to do is we need to focus a ray of light such that it gets reflected. So for that we will make use of a laser light. So let us now try to project the laser light. So when you project the laser light, what happens? Though we can see the points, but we really do not see the line. So let's do something. Let's pour some water into this container. So now that we have poured some water, let us again try to focus the laser light. So you see, even now we cannot see it very clearly. The rays are not seen very clearly. So let's do another thing. Now in this water, let's add a few drops of Dettol. If you want, you can also add some detergent solution or soap solution. So just a few drops will do. But make sure once you add this Dettol, you mix it well with the water. So now once you have poured water and Dettol solution, please make sure that the mirror is upright, because there are chances when you put water it might get disturbed, the arrangement might get disturbed. So just confirm that, and then we again project the laser light on the mirror. Now what do you see now? Now you can see the rays, but to see it even better, what I would suggest is switch off the lights in your room. So that would give you a better view. So now you see, you can very clearly see the rays. Right? So you can very clearly see the incident ray and the reflected ray. So this angle between the incident ray and normal is angle of incidence, and the angle between reflected ray and normal is the angle of reflection. So if you look at the reading on the protractor, you can see that the angle of incidence is equal to 30 degrees. And similarly, when you look at the angle of reflection, you see that the angle of reflection is 30 degrees again. So this proves that the angle of incidence is equal to angle of reflection. Now see what happens when we change the angle of incidence. So here we have increased the angle of incidence. So now the angle of incidence, that is this angle, is 50 degrees. Right? Now when you look at the angle of reflection here, so here also you see that the angle of reflection is also 50 degrees. So again, angle of incidence equal to angle of reflection. So if you now decrease the angle of incidence, so as you can see here, the angle of incidence is decreased to 20 degrees. So what is the angle of reflection? The angle of reflection again is 20 degrees. So in this way, with this experiment, we see that in all instances the angle of incidence will remain equal to the angle of reflection, which proves the first law of reflection. The second law states that the incident ray, the reflected ray and the normal, they all lie on the same plane, which is very evident from here because all of these lie on the same sheet of paper.
I think you understood the relationship between angle of incidence and angle of reflection. So take page number 27 of your textbook. Here you can see a table in which angle of incidence and angle of reflection has to be marked. The first one, it was given the 30 degree of angle of incidence. What could be the angle of reflection? If the angle of incidence is 30 degree, the angle of reflection will also be 30 degree. That is, from the experiment we found out that the angle of incidence is always equal to the angle of reflection. So the second one, if we have taken 40 degree as angle of incidence, the angle of reflection will be 40 degree. And the third one, if we have taken 45 or 50 degree of angle of incidence, the angle of reflection will be 50 degree. So here I have taken 30, 45, 60 and 80 degree as angle of incidence, and I have marked the angle of reflection. Like the same way you can do this in your textbook. This is a plane mirror. Stand in front of a plane mirror. Raise your left hand. Which hand of your image is raised? Is it the left hand? No. You feel that you are raising the right hand, or the image formed in the mirror will be having the right hand raised. So what occurs? Change your hand, that is, raise your right hand, and observe which hand of the image is raised in the mirror. What change occurs to the image? Our right side appears left and our left side appears right in the image, isn't it? Such a shift of the lateral side of the image in opposite direction is called lateral inversion. So lateral inversion occurs in a plane mirror. That's why we feel that when we raise the left hand, the image will be having the right hand raised. If we raise the right hand, the image formed in the mirror will be having the left hand raised. So this is called lateral inversion. So the right-left change occurs in the image of an object on a mirror is called lateral inversion. The word lateral means the sideways, that is, change in the sides of an image in a mirror. Let's think. You have seen an ambulance, isn't it? What could be the reason for writing the ambulance in a reverse manner? So when you see an ambulance, you can notice that ambulance in that vehicle is written in a reverse manner. What could be the reason for that? It is because a driver on other vehicles can easily read it through the real view image of the vehicle. So, the properties of the image formed by a plane mirror can be summarized as follows. The size of the image will be the same as that of the object. The distance between the image and the mirror is equal to the distance between the object and the mirror. The image will undergo lateral inversion. So these are the properties of the image formed on a plane mirror. This is all about today's class. Hope you all understood. Thank you. Have a nice day.